Hello friend, welcome to my channel. Today we will solve the LeetCode daily problem. That's the linked list based problem. In this is a LeetCode 141 problem, linked list cycle. Okay, in this problem it's just a return true if there is cycle present or not. If cycle is not present, then it return false, and if cycle is present, then return true. This is only this 4 and 5 line mention. Okay. We will see the first example. There is a 3, then 2, then 0, then -4, then our cycle goes to 2. In this case, cycle will be present. We will just check if the cycle is present or not. If cycle is present, then return true, and if cycle is not present, then return false. Okay, then we will check the next example. Example number 2. In example number 2, there is a first 1 and then our pointer goes to 2, and after that 2, we will back again to the 1. In this case, the cycle is present. At that time, we will return the true. Don't worry about the position of that. Position 1, position 0. It's only check if cycle is present or not. Okay. Example number 3. In example number 3, we will see the our only one and there is no any pointer in that answer cycle in that. That's why we will return the false. Okay. For checking the cycle present or not, my first approach goes to the set, because set is store the unique addresses and unique number, unique character and unique string. Okay, you know all that concept. Why we use the set? Because of that, for this three there is only a unique address. For this two is unique address, 0 unique address, -4 unique address, and if you go to the 2 again, then that's address of the 2 we will see in the set. It's in this set our address will be present or not. If address is present, then we will return the true. Cycle is present. If address is not found at the end of that set, then we will return the false. Okay, first we will see the our set solution. Okay, you all know about the declaration of set. This is a set declaration. Is set list node star and st. We will use list node star because of the we want the our pointer address for our temp. Okay, for example, this is our 3 and this 3 list node we will two value. One is a value and second one is the address. We want the address. For that we will use the list node star. Okay, uh, for that set we will declare set as st, and we will list node start temp. We will create the temporary node and we will assign to head. Okay, for that we will just traverse that node from starting node to ending node. Okay, while temp not equal to null, because of the our temp is goes to here and our is a null, then we will directly say there is a no cycle will be present in that our example. Okay, in this case, while temp not equal to null, if just see the set operation, our our uh, our address will be present in the set or not. If address is already present, then we will return the true. Otherwise, our set will be insert that temp and temp will be go to the next. Temp is equal to temp to next, and after that we will not found the any sequence or any cycle in that case, then we will return the false as earlier as I told you. Okay, our next this is a this approach. Okay, for this time complexity will be O of n and space complexity of O of n. Time complexity of O of n, because of the we will traverse all the node from the first to the end like this: temp, 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 temp. We will traverse all of the node. That's why we will just say the O of n is a time complexity of that's our approach, and space complexity will be O of n because we will store all the addresses again and again. For this 3 we will store address, for this 2 we will store address in set, for 0 we will store address in our set, and -4 we will also store the address. That's why our space complexity and time complexity will be O of n. Okay, for next approach I have another one approach for the solving this type of question. You know all about the two pointer approach in the node. For the two pointer, we will call the Floyd. For that two pointer, our algorithm will be Floyd, Tortoise and Hare algorithm. Okay. For the Floyd Warshall and the Hare algorithm, just say the slow will be go to the 1 1 position and our fast will go to jump of the 2 position. For example, we will apply our slow and fast approach on this example. Okay, our first slow and fast will be pointing to the 3, then we will go to the 2 and our fast will be go to the 0 because fast will be jump to the 2 position. Okay, after that 2 we will just go to the 0 and our fast pointer will goes to the 3, and after that 4 minus 4 our fast pointer will be here, and in this 3 our fast and slow will be meet again. That's why we will that time we will say return true. Okay, we will just run that code and I will explain. See, our two pointer approach, there is a slow and fast will point to the 3 as earlier I told you, and our stopping condition for this is a while fast is not equal to null and fast is next not equal to null, because for example our fast pointer will be here and for example our end will be here. Okay, at that time we will just see our fast, because of the our fast will go to the 2 jump, that's why we'll check fast is not equal to null and fast next is also not equal to null. Okay, and as earlier as I told you, our fast pointer will be goes to the 2 position ahead and slow will be go to the 1 position ahead. If both are the meet, then we will return true, and if no one meet, then return false. Okay, this is our solution based on the 2 pointer slow fast. Okay, for that for in this question our time complexity will be O of n and space complexity is O of 1, because we don't store any addresses here and any other node. That's why our space complexity will be O of 1. Okay, I will just run that code and see. Okay, thank you everyone.